This section of video is going to talk about a term called concavity. If something is concave up, you've probably learned this in a science class. Concave up, it's going to curve like this, so it's opening up. Concave down, it will open down. And we're going to learn eventually how to use the second derivative to help us figure out if a function is concave up or concave down, and this will be useful for lots of different applications. So I'm going to ask you to look at this picture here a second. This right here is going to be the original function. This is the derivative, and then down here eventually we'll be writing the second derivative. I want you to think about where the concavity changes on the original graph. It looks like it's probably right about there. And so I'll do this in red. From here, it looks like it's concave down, and then where it changes, we're now concave up. And we're going to look at some of the differences with the first and second derivatives in relationship to where this concavity changes. So if we were to look at the second derivative, we're going to try to match some things up. So I think you can kind of see it's x cubed or something related to x cubed for the original function, and x squared for the first derivative. That makes sense based on what we've been talking about, how the degree goes down by 1 as we take derivatives. But the place where that concavity changes kind of matches up with this part right here. And wherever it was concave down, the original function was concave down, it's going to match up with this portion of the first derivative. So the first derivative is decreasing when the original function is concave down, and the first derivative is increasing when the original function is concave up. And that actually matches up with what our definition of concavity is. Okay, a function is concave up when the first derivative is increasing, and it's concave down when the first derivative is decreasing. That's the official definition. But there's going to be an easier way to figure out concavity, which we'll learn in just a second. So let's go back to that first set of lines. Okay, so let's try to come up with a sketch of what we think the second derivative might look like. And so right here we know that the tangent line for that would be 0, so I know it's got to go through 0 right there. And if we're looking at the first derivative, all of these tangent line slopes would be negative, steeper right there, not as steep right there. Here they're increasing, pretty steep right there. I should say the slopes are positive here, more positive, larger numbers for that, and not as large right around here. So I'm actually just going to end up with some sort of a line going up like that. And again, wherever the original and the first derivative were shaded in red, it's going to look something like this. And wherever it was shaded in blue, it matches up with this part. And so for the second derivative, we're looking at where things are positive and negative. When the original is concave down, the second derivative will have negative values. And when the original function is concave up, the second derivative will have positive values. And so we're going to fill in some notes here. This basically summarizes what I just said when we were looking at the picture, but that's what we're going to call a concavity test. Concavity test says to see where it's concave up, look where the second derivative, it should say greater than 0, and where it's concave down, look where it is, the second derivative is less than 0. And that's going to be maybe a simpler way of going through all of this. You see some funny pictures there. This could be one way to solve it. If you have a happy face, it means the second derivative is positive, so it'll be concave up. If the second derivative is negative, it'll be concave down, if that helps you remember that a little bit better. Okay, let's go through one quick example of this. We're looking at the function negative 2x cubed plus 6x squared minus 3. We want to know where it's concave up or concave down, and we just learned that to do that we need to look at the second derivative. So the first derivative, g prime of x, would be negative 6x squared and plus 12x, and nothing after that. And we are interested in the second derivative, which would be negative 12x plus 12. And it just so happens that this factors kind of easily. It might be nice to see that it's going to relate to, let's see here, we're going to factor out a negative 12, so that would be, just want to make sure I'm doing this right, that would be, can we erase here? There we go. That would be a minus 1 right there. Okay, so we want to know, when will this whole thing equal 0? When will the second derivative equal 0? And that's only going to happen when x equals 1. Okay, so we kind of know the cutoff point now. We know where it might change concavity. Now we just want to kind of make sure that it does work out. So that's kind of a separate set of work here. We're going to make a sign chart for the second derivative. Our point that we're interested in is positive 1. And so if I plug in maybe a value of 2, figure out what the second derivative will be over here. If I plug a 2 into this, let's say, I would get something that is negative. And if I plug in a 0, so something that's on this interval, I would get something that's positive. And so remember that our test says wherever the second derivative is positive, it's concave up, so it'd be going something like this here, and here it's concave down, so it's something like that on that side. That's what the original function would be looking like. So here's how we write out our final answer. I'll just give you one of the sets of answers here where it's concave up. We'd say that function g, we actually name the function, it's concave up on a certain interval, so from negative infinity to 1, that's a set of x values, and here's the reasoning, since g double prime is greater than 0 on that same interval. That would be the proper way to notate an answer like this. And then for concave down, you would basically just switch a few things around, but the same sort of reasoning. So jot down any questions. We'll see you in class.